Hi, everybody, again. And we are going to continue this course with Chapter 4. Chapter 4 is about cryptography, and there are two main topics that will be discussed in this chapter. The first topic is definitions of cryptography. So we will define what cryptography is, and we'll define what encryption as compared to cryptography, and the different components associated with cryptography. As soon as we finish the understanding of cryptography, and we will continue with moving forward with the concept of encryption, and we will be discussing some encryption standards that exist. We will talk about two main standards that exist related to encryption. That is the private key or private key encryption standard, and the public key encryption standards. What's cryptography? Cryptography, it has been thought of before. It's about secrecy. It's about secret codes, spies. It involves the thoughts of different something like from that sort. Now, in reality, what is cryptography and encryption? That it is very important. It has a great application in our society, and every time, of course, think about it this way: every time you use your ATM card to draw money, you are using encryption and you are using cryptography. Now, so the encryption is what defined as the process of scrambling. Scrambling is mean modifying the content, changing the content of a file, message to make it unintelligible, means that ununderstandable. Okay, they cannot understand it to anyone not in possession of a key. So anyone who doesn't have the key for that specific message, he will not be able, or she will not be able to understand or unscramble the message back to its normal case. The first topic is definition of cryptography. So what is cryptography? Cryptography is the science of encrypting. Okay, when we encrypt, that is cryptography, or hiding information. Of course, it has been around for many years. Civilization have done it for over than 4,000 years. And the crypto system or the algorithms, okay, crypto system or algorithm has been in process or existed since then, and in order to encrypt or provide encryption to plain text. So that's why the crypto system is defined as an algorithm or the process or procedures to run plain text, or to turn plain text into crypto text. So the crypto algorithm is also known as cipher. Now, there are different elements in making effective crypto systems. So keeping in mind that crypto system or the algorithms, it could be simple or it could be complicated. First and foremost, it must be reversible. So the most important aspect of the crypto system or the algorithm that is being used in the encryption, it must be reversible. So if it cannot be reversible, it cannot be decrypted, or the message you cannot obtain the original message back again. So now the types of algorithm or crypto system, there are different types, and the security of crypto system should be dependent on the secrecy and the length of the key. So there are two important aspects of the algorithm: the secrecy and the length of the key that is needed in order to make the algorithm. In other words, knowing the algorithm should not make it significantly easier to crack the code. So even if you know the algorithm, it should be difficult for people to crack the code. This is what we call it restricted versus unrestricted. Now, it is also important that the algorithm has has been subjected to substantial testing or a cryptanalysis. Without having a cryptanalysis on the code or on the algorithm itself, this could be this could make the algorithm or the crypto system vulnerable to attack, because it has weaknesses, and there are possibility of exploiting exploiting these weaknesses. Theoretically, every algorithm is broken or can be broken by way or another, because they are human made, and anything that the human make could also be handled or altered by the human. So, however, the algorithm should not contain an inherent weakness that an attacker can easily exploit. Now, the example of let's take this example that I provided in 1.2 here, an example of a certain cipher. The cipher is also the algorithm or certain crypto system. It's a very simple example. We have two rows. The first row is the letters that we use in our messaging or our text, and the second row represent the map to every letter that we are using, or to convert it into the number or letter in the second row. So this is why by itself we call it a cipher. So this is like a code that we are going to be using. Now, to unscramble a message, we need to match each letter or the number in a message to a corresponding number or letter in the second row and convert it into the letter in the first row. So scrambling is from one way you convert from the original letter into the map letter. This is you are scrambling. Now, if you want to reverse it, then you need to look at the cipher text or the cipher message, and you map those characters back to their original state. This is provided here as an example on this diagram, and it shows that you get a cipher text and you get a clear text, and it shows that this is using a simple cipher, and this is very simple cipher, but this is good only for keeping the message secret, not too for a very long time. So unless the cipher or the code is complex, it's definitely the code is breakable. And as indicated before, this doesn't comply with one of the qualities of a truly effective cipher. Okay, where knowing the algorithm should not make it significantly easier to crack. Now, ciphers they fall into two categories. The cipher itself, it's either a stream of data or ciphers, or a block of ciphers. Now, a stream, the previous example that we had, it is a stream cipher. So stream cipher algorithm process the plain text to produce a stream of cipher text. Now, a cipher input, the plain text, and a stream, and the output is stream text. There is a figure here, figure 3-1, illustrates the concept of a stream cipher function. Now, stream cipher have several weaknesses, as we have indicated before. The most crucial shortcoming or weaknesses of stream cipher is the fact that if we know the patterns in the plain text can be reflected on the pattern of the cipher text, and by multiple trials it is very possible to crack the code or to know the original code. Again, also, patterns in plain text are reflected in the ciphertext words. There are certain repetition could be based on the repetition. We can really establish analogy to identify the original code. Now, in English also, there are certain letters that appears more often than others. For example, the letter E, T, A, O, N, and I, those appear, and there are the least letter that can appear in the English language are J, K, X, Q, and Z. And if all these taken into consideration, and with some kind of training, it's very possible to be able to break the type of code. Now, there's another weakness of stream cipher is that they can be susceptible to substitution attack. In other words, there it is possibility that, you know, while they are transmitted, it's possible that to take part of those codes and being substituted by another code. So in this way, the code is breakable in the middle. This type of replay, they call it a replay type of attack, where someone can simply copy a section of an old message, okay, and insert it into a new message. You will never know that if this was broken, because the stream of data is a continuous stream, or there is a stream of data. Example of cipher that includes stream ciphers, or the stream ciphers example, there's a Vernam cipher, there's a Rivas cipher, or RC4, okay, and one-time path. Now the next type of ciphers that exist, they call it block ciphers. Now, block ciphers, it's differ from stream ciphers in the sense that it encrypt and decrypt information based on a fixed size, of blocks, rather than encrypting and decrypting each letter or word individually. A block cipher passes a block of data or plain text through its algorithm. So the algorithm is more complex. It's not based on character by character, or alphabet by alphabet, or word by word. It's a block, and the block could be different size, and this will make it the size of the block and the number of the block that can be ciphered together or encrypted together. This is what makes the cipher difficult to crack. So a cipher that generates a block of ciphertext that is significantly larger than. So in fact, that we need to make sure that the generated cipher from the block should be smaller than the original information, because we don't want to have or to overutilize the bandwidth. Okay, so if the ciphertext block has twice the size of the plain text, the net effect is that your bandwidth would be cut in half, and this is not going to be acceptable, because an encrypted file of 10 megabyte in size would be 20 megabyte in size when encrypted. So encryption should take into consideration the size of the block and how the block will be implemented. Another requirements for block cipher is that the ciphertext should contain no detectable pattern. So the ciphertext should contain no detectable pattern, and to ensure that whenever, even if the code is even if you have certain pattern, it will not be detected. Now, example of well-known block ciphers include, there's a data encryption standards DES and International Data Encryption Algorithm IDE. Now there is also SKIP or skipjack type of block ciphers. Now, breaking ciphers, any code or cipher could be broken because there are people trying to break them, and there are many methods employed to break cipher. Some methods are ingenious, some methods are primitive, sophisticated, and technical in nature. Some require different mathematical modeling, and so on. Now, the next topic of our discussion today is going to be about encryption. Now, we introduced the cryptography, we introduced the cipher, we introduced the type of cipher, stream ciphers versus block cipher. Now we move into encryption. Now, what is encryption? Encryption is the process of scrambling the content of a file or message to make it unintelligible to anyone not in a position of a key required to unscramble the file or message. So there are two types. So as a continuation to cryptography, there are two types of encryption: symmetric or private or secret, symmetric, private or secret key, and asymmetric, that is public key encryption. Now we start with symmetric type of encryption. When most people think of encryption, they think about it, and it is symmetric key crypto system. Symmetric key, also referred to as a private key or secret key, means that you have to have that private key in order to break the code. and it's based on an algorithm being shared between two parties or who are exchanging encrypted information. Now, the same key both encrypts and decrypts message. So we are using the same key from the source. The plain text is being encrypted using the secret key, and at the other side, the decrypted message is being decrypted, or the cipher text is being decrypted using the same secret key. Now, the main weakness of the system is that the key has to travel across the network. And when the key is traveling across an unsecured network without having a proper security standards, this key could be compromised, and this key could be known. As a result, private key crypto systems are not well suited for spontaneous communication over an open network, over unsecured network. So in addition, Symmetric provides no process. There is no process for authentication or non-repudiation. Okay, remember, non-repudiation is the ability to prevent individuals or entities from denying, okay, their identity. Okay, a message was sent or received that or file accessed by someone. Okay, they could deny this if they are being sent utilizing this encryption standard. Now, table 3.2 lists the advantages and disadvantages of symmetric key crypto system. Now, the advantages of the symmetric or private key, it is fast because it's using a small code, a small block, okay, and relatively secure, okay, and widely spread. Relatively secure because, you know, on a private network, you know, this could be secured, and also it's widely spread. But the disadvantages, it requires secret sharing, sharing the same key. Also, it requires complex administration, and of course, the most important one is that no authentication. Okay, authentication that is related to there is no repudiation. Okay, and that's a very important key, is that to identification of the identity of the person. There are the same examples. By the way, the symmetric encryption standard is very similar to what we have discussed regarding the block, the streaming block cipher, not block, the streaming cipher or cipher, the streaming cipher, and the standard that are being utilized here. It's DES, data encryption standard, DES3, IDEA, Blowfish, RC4, CAST, and Skipjack. So those standards are similar to what we have discussed previously. Now, there's one standard, you know, we can just highlight this standard, which is called data encryption standard. Data encryption standard was initiated in 1973 in response to RFP, or request for proposal, issued by the National Bureau of Standards, which is now known as National Institute of Standards and Technology, NIST. Now, the sender and receiver of the message should obtain the same key, or shared secret or private key, of course. Cryptography keys are involved in symmetric encryption. Key management is essential at all stages of the data transmission, starting from the sender all the way to the receiver. These are just some highlights of the data encryption standards, that is symmetric or private encryption standard. Now, the other type is asymmetric encryption. Asymmetric encryption is for centuries, for a very long time, people thought that they are only going to be using symmetric or private key crypto system. But in 1975, this is the change. Two computer scientists, Whitfield DeFi and Martin Hellman. This is what they are referred to. Those two people from Stanford University introduced the concept of asymmetric cryptography. Asymmetric cryptography is also known as public key. cryptography means that the key is known to the public. Some highlights of asymmetric encryption. The public key cryptography uses two keys as opposed to one key. So one for symmetric system. With public cryptography, there is a public key and private key. So the public key cryptography, there is two keys, the public key and the private key. Now the keys' names describe their function. One key is kept private and the other key is made public. Now knowing the public key doesn't reveal the private key. So the private key stays private. A message encrypted by the private key can only be decrypted by the corresponding public key. Conversely, this is true. Now, this is invented by Whitefield, DeFi, and Martin Hellman in 1975, known as public key cryptography, and uses a pair of key, a private, which is secret, and public key that could be sent to anyone else. The following diagram shows this standard asymmetric encryption. And again, the examples of asymmetric encryption includes the RSA, the DeFi-Hellman, ECC, El-Gamal, are all examples of public asymmetric encryption protocols. Thank you.